what if you were to get a matrix of the form 1, 2, 1, 3 to the minus 4, and you were to solve this matrix using the inverse method? Now, first, what you're going to do is to say the inverse of A is equal to the adjoint, which is A adjoint over the determinant of matrix A. So what we're going to do first is to find the determinant of matrix A, and this is given by the symbol A, and this is equal to 1 multiplied by minus 4 times 5, which is equal to minus 20, minus 6 minus 2 times 15 minus 10 plus 1 open bracket 9 minus 20. So next in line we're going to say 1 open bracket 20 plus 6 minus 2, and this is 15 plus 10 plus 9 plus 20. So what we're going to have is we're going to end up with a minus 14, and this is 2 times 25, which gives us a minus 50 plus 29. So the result for this determinant A is minus 35. So with minus 35 being the determinant of A, what we're going to do next is to find the adjoint. And the method that we're going to use is the cofactor method. And how you find the cofactor is, say for example for this 1, you're going to write all the numbers that are not included in the row and the column that 1 is. So we're going to have minus 4, minus 2, 3, and 5. And for the next number 2, what is not included is 3, minus 2, 5, and 5. And for number 1, what is not included is 3, minus 4, 5, and 3. And we're going to do that for the next element, number 3, which has a minus 2, 1, 3, 5, and the next element minus 4, which have a positive sign, and this is 1, 1, 5, 5. And the next element, the minus sign, we have 1, 2, 5, 3. Now we're going to do the same thing for 5, so we end up with 2, 1, minus 4, minus 2, and we have a minus sign, so we're left with 1, 1, 3, and minus 2. And then we have a positive sign for this element, number 5, so we end up with 1, 2, 3, and minus 4. So that is how you find the cofactor. Now what we're going to do is we're going to find the determinant of each of the matrix in the cofactor. Now make sure you take off this. Now what we're going to do next is remove this, and the determinant for this is minus 20 minus 6, and then now finding the determinant for all of the element to give the element itself. So we end up with a minus, open bracket, 15 minus 10, and a positive 9 minus 20. And for the next element, we have a minus, and we have 10 minus 3, and then a plus, open bracket, 5 minus 5. Then we have a minus, open bracket, 3 minus 10. And then for the next element, we have a plus sign outside, minus 4, minus 4. Then minus sign for the element 2, minus 3. Then we're going to have minus 4, minus 6. So what we're going to do now is to try and get the cofactor. So what we're going to have is minus 20 plus 6, so we end up with a minus 14, and 15 plus 10, we're going to end up with a minus 25 because the sign is minus, and then this is going to be a positive 29, and then we're going to have a minus 7, 0, a positive 7, and minus 4, end up with a 0, and minus, so end up with a positive 5, and that will give us a negative 10. So that is the cofactor. That is the cofactor for the matrix A. Now what we're going to do next is we're going to find, this is the cofactor and it is denoted by the C. So what we're going to find is we're going to find the transpose. So with the cofactor, we're going to find the transpose of this cofactor. And remember, how you transpose this element or matrix, you should turn all the rows into column or all the columns into row. So what we're going to do next is write minus 14, minus 25, and 29. Then we're going to write minus 7, 0, and 7. Then we're going to write 0, 5, and minus 10. And that is the transpose of a cofactor. So what we're going to do now is A inverse is equal to 1 over the determinant times the transpose. So we're going to change this to A inverse, and this is equal to 1 over minus 35 times the transpose, and this is going to multiply by the constants on the right hand side of the equation. So what we're going to do next is we're going to multiply the constants on the right hand side by the transpose first. So what we're going to do is 14 times 4, and that will give us a minus 56, and minus 14, because 2 7 is 14, and we get a 0 for the next. Minus 25 times 4 give us a minus 100, and 0 times 2 give us a 0. 5 times minus 1 give us a minus 5. And remember, this is going to multiply by 1 over the determinant to see what is the value of x, y, and z. Now 29 times 4 give us 116, and 2 times 7 leave us with a 14, and let us bracket these because we're supposed to add or subtract them. So, and we get a plus 10. So what we're gonna do next is, now like how this part of the equation is fully multiplied, let us add the number in each to see how much we will get. So A inverse is equal to, open bracket, now minus 56 plus minus 14, this gives us minus 70. And 100 minus 100 plus minus 5 leave us with a minus 105. And 116 plus 14, that gives us with 130 plus 10, 140. And this should multiply by 1 over minus 35. So what we're going to do next is, we're going to divide each element by minus 35. So A inverse is equal to minus 70 over minus 35, minus 105 over minus 35, and 140 over minus 35. So what we're going to do next is, for the result, we're going to have x, y, and z, and this is equal to 70 divided by 35 give us 2, and 105 divided by 35 leave us with 3, and 140 divided by minus 35 give us with a minus 4. So what we can see is x is equal to 2, y is equal to 3, and z is equal to minus 4, using the inverse of a 3 by 3 matrix.